right. Hi, my name is Noah Gift, and my presentation is using VS Code, Copilot, and Codespaces to level up to Rust from Python. So this is actually based on real world things that I've taught at Duke in the graduate data science program and also in the AI product innovation program. So this isn't theoretical. This is stuff that we've done in the real world, which is pretty cool. Let's go ahead and get started here. A little bit about my background. I'm the founder of Pragmatic AI Labs, which is a training company that produces content in AI and ML. Been doing that since about 2017. And I'm also an executive in residence at Duke. And a few things that are maybe relevant about my background is that I worked on the first 3D animated film for Disney and also for Sony ImageWorks. So it gave me a lot of Python data engineering, mindset. And this is actually way back in the day, almost 20 years ago. They were doing film pipelines in Python, and in fact, all those things are now really a big deal today. So in many ways, the film industry was a great start in my career. I've written 10 books, including Fly for O'Reilly. The latest one is Enterprise MLOPS. So I've been busy writing books. And I also was a real world founder in that I was able to build a sports social media company with millions of users and revenue from zero. And that was in the Bay Area. So that got really a fun experience in my portfolio of things to do. And it gave me a perspective on building things that, are scalable and work in the real world. And what I do currently, in addition to training, is do consulting with MLOps for Fortune 100 companies and startups. And then I also, as I mentioned earlier, am teaching Rust for the Duke data science program. So this is in person as well. So we're doing things like building PyTorch models or Hugging Face pre-trained models, deploying them into production type environments. And I've actually heavily utilized Copilot, Codespaces in these programs. And so really from the first day I got access to it, I've been embracing it. And I do think this is a huge value add to education, is to use things like GitHub Copilot. All right, let's get into the problem statement here and why I think it's so important to use things like Copilot. And I think the issue is that ChatGPT has changed coding. So if you're doing something previously where you weren't using ChatGPT, like again, you're using Python, using command line tools, web frameworks, all those kinds of things, it's important to realize that the world has actually shifted, almost like if one day the world was a blue sky and then you walk outside and then the sky is purple, right? Something's different. Like what happened? And everyone needs to have a strategy for using ChatGPT. And I'm going to talk about what I would suggest is a good strategy for using things like GitHub Copilot, ChatGPT, et cetera. So let's talk about the layered approach here in terms of getting the best outcome. So the first thing that we should talk about, and I will talk about it, is this cloud developer workspace advantage. So this is a huge value add in terms of using things like Copilot. In my opinion, it actually makes the system complete, and it's hard in some ways for me to think about using Copilot without using GitHub Codespaces. We'll talk about that a little bit. Also, AI pair programming, as I mentioned before, this is a critical component to using maybe more powerful languages like Rust. Also, DevOps is really critical just in the real world as well. A lot of times at a university level, people don't use DevOps, right? Because there's computer science, which is about the principles of computers, but then there's software engineering, which is about the application of software. So DevOps is more in that space. And so we do need to use DevOps to build production systems, continuous delivery, et cetera. And we'll get into that, how pair programming works very well with that. Also, I think another thing to consider is the age of the technology. So if you look at things like internal combustion engines, I think this is a perfect example. They've obviously been very successful. People use internal combustion engines, but everyone knows we're in a transition. And there are many transitionary technologies. For example, a BMW i3 has a 2-gallon motorcycle engine that can charge the battery, but it also has a battery that has, let's say, 150 miles of range. So that's a transitionary technology where the internal combustion engine is still used, but also the battery is used. Then you have modern electric cars like Teslas, Chevy, Volts, those kinds of things. And that's actually kind of the next generation. So I think people do need to be thinking about what is the age of your language and when was the language built? Python, obviously, again, just like an internal combustion engine, has been very successful. But how old is it? It's 30 years old. Are there new strategies that you could apply? And I think Rust is really one of the modern compiled languages that should be on people's radar. All right, so let's talk about GitHub Codespaces here for a little bit. And if we get into Codespaces, I think it fits into this paradigm that we're seeing now with all cloud providers, all environments where people are developing, is that there's this cloud developer workspace advantage. And we take a look at this picture here, you can see that a laptop or a workstation, there's some benefits to it, sure, but there's some problems as well. One of them is that it's non-deterministic. You don't really know what's installed on your laptop. You don't have 100% control over it because the software vendors or the hardware vendors have put things on your laptop. It also costs a lot of money. So if you wanted to buy a super fancy laptop, it could be thousands of dollars, and it's not going to be the same environment as the production environment. Now, you can use things like containers and virtual machines, etc. But still, there's some issues there that are important to think about. But if you look at what's happening in the cloud space, you can see this with Microsoft and GitHub with Codespaces. AWS has Cloud9, GCP has Cloud IDEs, Azure has Cloud IDEs. You see that there's this, really a pervasive layer of people are realizing that you want to have a disposable environment. It's preloaded with all the things you care about. And also, as I mentioned earlier, it fits really well with things like the OpenAI Codex, GitHub Copilot, GitHub Actions. They just work in a synergistic way. And so this is an important thing to consider when you're developing is, do you have access to this cloud developer workspace advantage? And how does it fit with things like GitHub Copilot? I've noticed that students have been massively productive when they're able to use the combination of GitHub Codespaces plus things like GitHub Copilot plus things like GitHub Actions. It's a really good formula. Okay, let's talk a little bit about GitHub for teaching MLOps. This is really the area that I focus in. Well, reproducibility, right? You can do this with Codespaces. You can also get access to GPUs, which I'm going to show in just a second. Also, as we mentioned earlier, AI Coding Assistant Copilot is amazing for teaching MLOps because of the code completion, and then the continuous integration and delivery, because this teaches students the real world coding, not just, hey, here's a notebook, let's go ahead and play around with a notebook, but let's actually deploy this into a production environment so we can use it. And that's, I think, one of the things that people are really starting to get interested in is, okay, I get that there's machine learning, but how do I use this to add customers or users? Or, let's just look at ChatGPT. It's wildly successful because they deployed the model to the users, right? That's really a critical thing that everybody needs to know in the ML ecosystem. So let's talk about how GPUs in teaching as well add a huge impact, because a lot of times, you may have a GPU on your machine, but what is it? Is it an AMD GPU, or is it a Mac GPU, or is it an NVIDIA GPU? You have all these different flavors. But again, by focusing on a cloud-based environment in terms of teaching, prototyping, even doing production workloads, it really is a huge enabler, right? And so it allows you to do things like fine-tune models, which I think many people are interested in doing for large language model development. Hugging Face is a great example. Dolly from Databricks. You can also use pre-trained models and test things like summarization. You can do CUDA programming, right? You can drop down and start doing GPU programming yourself. You can do bespoke training. This is also a thing that is really a struggle for many universities is, how do I get students to train models? Well, you can use a GPU that's inside of GitHub Codespaces. And then inference, right? Once you're done with the model, you have to do inference. And if you have a CPU, it could just be 30 seconds or 60 seconds to do inference. But you can get really fast inference by getting this inside of your code space. So it's really a game changer to have this as part of your stack as you're developing. As I mentioned before as well, GitHub Copilot is amazing because it allows you to really accelerate your code. I think in terms of some of the stats that we've seen, the CEO of GitHub actually was a guest lecturer in my class at Duke, and he mentioned that in some cases there's 80% of the code that's generated from Copilot goes into production. So it's obviously a very successful technology. And as I mentioned before, everyone should have a strategy. So here's the strategy that I would recommend, even if you don't level up to Rust, if you're still sticking with Python or JavaScript, et cetera, is think about this feedback loop. So at the top here, we have a prompt, right? In terms of the prompt, that's where you decide, what kind of question you're going to ask the AI pair programming tool. But then the part that's really critical is that because there's things like hallucination, or maybe you didn't frame the prompt correctly, you need to have a robust DevOps infrastructure. So you should use things like PyLint or Rough, or some kind of linting tool, or in the case of Rust, they have Clippy. You should also have some tests available. Again, you can have pair programming tools help you write the tests, and you need to execute the code, maybe build a command line tool so you can look at the code and then format your code as well. So this is a critical part, is the ecosystem of your language, whether it's Python, Rust, et cetera, fits very well with the pair programming feedback loop. So this is a critical component to getting the best out of these AI coding assistant technologies. And finally, as I mentioned before, why not have a new strategy, right? If Python itself, the reason it was invented was to make things easier for the humans, which is a great reason, right? And I've been very successful with Python. But what if we now don't have to care as much about the humans, and we can care a little bit more about the machines? In the case of Rust, you can get in some cases, 2,000 times better performance, right? So that could save a company a lot of money. It could save the environment. So it is actually interesting to think about Rust. So what are some of the things that we care about in terms of MLOps, which is something that is really on the radar of many people, many organizations? Well, high-speed execution, right? That's one of the really big ones that you can get. Memory safety as well. So this is another one that, with scripting languages or C or C++ or 30, 40-year-old languages, there are huge security issues. So if you use a modern language like Rust that's designed for safety, you could actually eliminate a whole vector of attack, which in many industries, maybe defense or finance, this could be a big deal to eliminate this. Also, concurrency. I think older languages like Python were, again, wildly successful, just like the internal combustion engine, but they don't do parallelization as efficiently as some of the modern programming languages. Like in the case of Python, there is the GIL, the global interpreter lock, that really is a bottleneck in terms of doing multi-threaded programming across a multi-core machine. And also binary deployment. This is also a really big issue with languages like Python, Ruby, et cetera, is that there is no concept of binary deploy. A binary, in the case of Rust or Go or C#, you can just give somebody this code and it maybe has a model in it and you're good to go. So there's some significant benefits. Although Rust is a hard language, you do have benefits that you get from it. Finally, what about Rust libraries for machine learning, data processing? There's actually amazing bindings for PyTorch with Rust. There's also Linfa, which is a machine learning algorithms library, just like, let's say, scikit-learn. There's Polars, which is even in Python, it's been taking the world by storm. Very fast performance. And then Onyx, which is from Microsoft. It's a package that allows you to have a really uniform model format for PyTorch, TensorFlow, MXNet, those kinds of deep learning frameworks can all fit into MLOps workflow. So really, there's this ideal scenario here for machine learning with Rust. All right, so we talked a lot about theory. Let's get into some practice here. So I'm going to go into a repo that I've set up here that highlights a lot of the stuff first in Python. So this is called Nogi BJJ MLOps template. And if we take a look at some of the things I've got here, notice that I use this dev container so that I have a reproducible environment. What do we have inside of here? We have a Docker file. And inside of here, I can put NVIDIA drivers. I can put all the Python libraries that I care about. All the stuff is all set up for me. In fact, I can even put Python pip inside of here, the virtual environment. Everything's all set up so that when I launch it, it's good to go. And inside of this .dev container, You can also go to the devcontainer.json file, and you can tweak things as well. You can add features like, do I want to install the CUDA drivers? Do I want to install Kubernetes? Do I want to, use certain linters, et cetera? You can configure all that stuff automatically. So it's an amazing time saver because a student or a coworker can just fork this and be ready to go. Now, how would you use this? Well, pretty easy, actually. All you have to do is you just say code right here. And notice by default, it'll launch a code space with a 2-core machine. But if you select this icon here, what's really cool about it is it will allow you to configure new with options. So if we say new with options, take a look at this. We've got 2-core machines, 4-core machines, 8-core machines, 16-core machines. We even have really these monster GPUs, which I've been using in education, 112 gigabytes of RAM, and in fact, 128 gigabytes of storage, plus a really powerful NVIDIA GPU. Why is this such a big deal? It's such a big deal because this was inaccessible to many students before, and now all I have to do is they click a button and they've got a Python-based MLOPS environment. In fact, I've already done that. I've already got this set up, and let's take a look at how I got it to set up so quickly. There's a secret little feature here that's kind of cool to know about called settings. And if you go to the settings and you go to Codespaces right here, you see this, it's called pre-build configuration. So if you set up a pre-build, it'll already be baked out and ready to go. I have a CPU version and I have a GPU version of the pre-build, and it basically it's ready to go. And if I go and I click this button again and I say new code space, it just launches. So I've already done that. And you can see right here that this is the environment. So this thing's set up, and you can see that, in fact, when I launch it, it automatically has a Python virtual environment, and it's got everything set up for me. And one of the ways that we can tell that the GPU is enabled is if I type in NVIDIA SMI -L1. If you install the NVIDIA driver, it'll show you the basically the GPU monitoring. But in a nutshell, what I typically will do when I first start up an environment is I go to utils right here, and I would just go ahead and run some kind of installation. So if we go into utils here, and I want to test something, I would say maybe let's test PyTorch, right? I go through here, so Python quick start, PyTorch, and I can just kind of kick the tires on whatever it is that I'm doing. And again, this saves so much time because I think many people are overwhelmed with doing things like GPU programming, setting up drivers, installing all this stuff. And you can see here that all someone has to do is literally click a button, they get a GPU, and they can start training a model. And you can see the results right here. And now this is the Python version. But one of the things I want to show next is the Rust-based version of this. So if we go to Rust, and this is something that I used in the Duke class just this last semester, is I've got the same thing set up, right? I have a dev container, I have a Docker file, this goes through, it installs Rust. Now, this is one of the killer features here of Copilot and Codespaces is that you can save from Microsoft, and you can get a official container here that contains the language that you care about. There's tons of officially supported languages. In this case, I just grab Rust here. I install a couple other features, and then I'm again ready to go. So if we go over to the Rust version now, let's go ahead and restart this thing so it launches again. Again, it's super fast to launch it because of the pre-builds that I've set up, and I can just start trying out a new language. So it really, in a way, there's training wheels that are available for you if you use a code space that's already been set up, and you also use Copilot. It enables you to really quickly get up to speed with using a new language. So let me show you a couple things that you could do really quickly here. So with Rust, what's a little bit different versus Python, in Python, you have to have some, understanding of what's going on in your environment. With Rust, it's a little more straightforward in that everything gets set up inside of a directory, and they use a tool called Cargo. We go ahead and we say Cargo new, and we can just say, hello, Marco, something like that. And this will create a directory structure. And there, unlike Python, where there's pip and there's all these other things, you get everything already for you inside of there. So in many ways, it's actually easier, some parts of this than Python. And if we go over here and we look at this directory structure, you can see that under Hello Marco that this is the tree that's available in terms of a Rust project. If we type in tree right here, you can see that there's a cargo.toml file. The cargo file is where you would change and add different packages. So if we go through here and we say cargo, and we look at this, all you have to do to install some new package like a web framework or a command line tool or PyTorch, etc., you just put the name of it inside of here and it will install it for you. Likewise, you already get a source structure set up right here. So if we go to main and I wanted to run this code, it's actually pretty easy. All I have to do is just type in cargo run like that, and it compiles it and it builds it for us. So by getting the Codespace environment set up, getting it all configured, it really allows someone to very, very quickly, create a new project and get up to speed. Now, we haven't yet touched on the Copilot aspect of it. So how could we do this? Well, pretty easily with Copilot, what we could do is we could start to use our prompt engineering to help us out. So we can say, build a, add function that I will use, right? We can start to kind of give it some ideas, and then here, very similar to Python, not too different, is you just put in a new function name. So we could just say, add function like that. And what'll happen is Copilot is so smart, depending on how you prompt it, it'll actually give you the function that's available. In this case, we say add, and Python also has this optional typing in Rust is required. You can see that it says here's an A and a B, and these A and the B will get added together, and there's an explicit return that's available with Rust. And so all we would have to do now is just call this function inside of our code. So let's go ahead and do that. We'll just say, basically results is equal to, and again, Copilot will help us out. There we go. And now we should just, change this print so that it does that. It includes the result. So we can say hello world. And again, Copilot here will help us out. So by having a robust ecosystem like GitHub Codespaces, plus having this functionality available in terms of the linter, the formatter, all this stuff, it really does make a big difference. So if we type in cargo run, let's go ahead and see if that works. There's a problem. It says results is not available in scope, and so we would need to fix this problem. We can say, here's the issue right here. The compiler is very smart. It'll just tell you what the issue is. Okay, we didn't put let. So in Rust, you need to just put let in front of a variable. We'll go ahead and we run it again. There we go. Hello world 3. Now, what I typically like to do, since we're running out of time here, is that I like to use a makefile to orchestrate a lot of things. So if we go over to another makefile that I've got set up, and I think this would be, let's look at another project, this one. What I can do is I can just copy this, and we'll just make a new one inside of this directory. We'll just do this. We'll just say touch makefile. And what's nice about this is that if you're getting confused about certain things, we can take away maybe a few of these things here, is that if you just want to do like common things inside of Rust and make it go smoother, a makefile will work really well with pair programming tools like Copilot. So how do we use it? We just do this. We just say make format like that, and it will actually format our code for us and make it clean. So a lot of times when I ask for a suggestion, I'll format it to make it look a little bit better. So again, if we go through here and we go, I don't know, something like that, and we, do that, and we just say make format, it should go through here. There we go, clean it up a little bit. So when you get a suggestion, you don't have to worry as much about what's going on. Similarly, in a makefile, you can add other steps like linting. For example, if I type in make lint and go from there, right? We have the ability to lint the code, format the code, and even do something called refactor. So I think this is an important way to really level up to a new language, is using a makefile with these kinds of steps, using Copilot, using GitHub Codespaces, and in many ways, it won't be as intimidating to use a modern compiled language, even if you're familiar with Python. And you may actually find that many things are actually a lot easier with Rust. And it doesn't hurt that in some cases it could be, 2,000 times faster to use the Rust language. So that's a good stopping point.
It was fantastic. I am a Carolina grad, watching a Duke professor talk about Rust bindings and a Pythonista, and I have nothing but great things to say about your presentation. And I just wanted to say thank you so much. I mean, this 2022 and 2023, we've had a really great story about the Python to Rust and Rust to Python integration, maybe. I mean, we have one of our top or one of our hotly used extensions in VS Code is the rough linter, which is written in Rust. So it's really interesting story to me, and I appreciate you talking more about it. And we do have some questions coming in about the Python to Rust. So will Copilot be able to help us with the Python to Rust and Rust to Python key bindings?
Yeah, so I think the issue is that, a lot of times when people are familiar with Python, they get a little bit concerned about adding a new language like Rust. Is like, hey, well, why would I do that, right? I already know Python, and Python's so easy to use. I think the way to think about this is that all of the skills you already have in Python are still available, right? So you can write functions, build command line tools, but the difference is that you use those skills that you already learned to tell Copilot to help you write Rust, right? And so in a sense, you're still writing Python. You're just writing Python that's interpreted through Copilot and then comes out as Rust. And I think at the PyCon conference just recently, they talked about how there was a linting tool that was 2,000 times faster, right? They had a, the ability to, or no, it was the Pydactic, right? The typing tool. There's all these examples of people using Rust to speed things up. And I think, the way to think about it is not that you're necessarily abandoning Python. A lot of the stuff you've already learned can get translated to Copilot, which then lets you spit out the Rust code. And then you can use the same things that you've learned over the last, 5, 10, 20 years and still use those techniques but just with a new language.
I really appreciate that lens on it, and it gets me more excited to jump into Rust. And I was at PyCon just a few days ago, and one of the other hot Rust options or projects is the rough linter, which is one of the really widely sought after extensions in VS Code. It's a community contributed extension by Charlie R. Marsh, and it's I really enjoy the story, and I appreciate you filling in the gaps for me.
Yeah, I love seeing the excitement. I am not like a Python or Rust person, so this is really fun for me to be here. So one question that I also have is actually, can you reiterate a little bit about what some of the fundamental differences in Rust versus other programming languages are?
Yeah, so I think, again, the idea of the car is a really good model, right? If, internal combustion engine, there's awesome cars, right? And people have been using cars forever, but things change, right? I mean, every period of technology, there's new changes, and there's some big advantages, right, to a electric car. I mean, there's no exhaust, right? You're not lighting things on fire. That's a big one. So same with Python. I mean, Python has been amazing, and Python has been very successful in many different domains, but it's 30 years old. And I think with Rust, some of the things that it solves, it's only about 10 years old, is that Rust actually has safety built in from the very beginning, right? So that's one of the big advantages. Also, it has binary deployment built in as well. So from the very beginning, you can just give somebody an executable and they can run it. That's something Python is not good at. Python's good at a lot of things, but you can't just give someone Python code and just runs. You need to know a lot of different things. With Rust, you can give an executable. Another one is the performance is just so incredible in terms of Rust. It's in fact at C++ level without doing anything, but it kind of looks like Python. It's not that much different. So it's an approachable language that has extremely high performance. I think that's one of the nice things about Rust. And then in terms of the security, right, the cybersecurity aspects of it, that's another big one, is that because the compiler is so rigid, a lot of the things that are bad programming things to do, like reassigning variables, things like that, you can't do. And then finally, in terms of concurrency, it's been designed to be massively concurrent. And a good example of this is AWS Lambda is, kind of a famous, serverless technology that a lot of Python people like. I don't know how many of them know that AWS Lambda is written in Rust, right? And so it's really good at building infrastructure type solutions.
Awesome. Thank you so much for that in-depth answer.
Yeah.
And thank you so much for being here today during VS Code Day.
Yeah, I'm so excited to dive into some Rust after this. This is great. I'll write my first line after this presentation.